Hello, everybody. Today, oh, thought I looked good. Plus, also thought I'd make a video. Um, Today's video is about math. If you're not into that, you can leave. But I think even the most, I wouldn't say dumb person, but even the most like knowledgeable person on this topic might understand what I'm going to teach you. Now, I'm by no means a qualified professor or a tutor of that fact. My experience only stems as far as teaching my peers, but I have consistently been on top of my class ever since I was young, and I have studied for tests that I should not have aced as much as I did. And I'm sorry if that's like bragging, I just really proud of it. Um, but yeah, so today we're going to learn about trigonometric functions. So I know you know what cos is. It's adjacent by hypotenuse and sine is opposite by hypotenuse. But what does that really mean, right? So here's something I learned very well. So the thing is, cosine and sine are not just functions of a triangle where you find the hypotenuse using the angles you're given for sine and then the adjacent value and then you find the hypotenuse. Although that can be good to start off to understand how the function works in detail, if you want to know what the actual function is, it is like this. See, if you're doing anything in math, there's usually something called a unit circle or the entire circle of 2 pi. Now, within 2 pi, the radius is always going to be 1, hence the name unit circle. Now, at any point in this unit circle, the position of the point can be given by a value of cos and a value of sine. Hence, if you are familiar with anything or you have any prerequisite knowledge, you might have seen around that x comma y can also be represented as a function of cos t comma sine t, where t represents the angle. Now, cos represents the x-axis, as you can infer, and sine represents the y-axis, again, as you can infer. Hence, you can also see patterns in the quadrants. You see, it always didn't make sense to me why cos was a certain way in a certain quadrant, or another way in another quadrant. But then, once I understood that they're representations of position and not arbitrary values based on radians or angles, it makes way more sense. Hence why cos represents positive values in the first and fourth quadrant, but then negative values in the second and third quadrant, because in those quadrants, the x value will always be negative, because on the Cartesian plane, the left side of the positive y-axis is always going to be negative of x, in a standard plane at least. Yes, and the right side will always be a positive x-axis. Hence, you can see that the first and fourth quadrant are always to the right of the positive y-axis, and the second and third quadrant are always to the left of the positive y-axis. Hence why you will see that the values will change for even sine in the third and fourth quadrant rather than the first and second quadrant, because in the first and second quadrant, y is always going to be positive because of the fact that the y-axis, the positive y-axis, is usually next to the positive x and negative x-axis or above it in a matter of speaking. Yes, again, it's not the most technical way to look at it, but it is the way I understand it, and I hope that it makes sense too. That is why if you take for any value of theta, so let's say sine of 45 and cos of 45. The values are the same because it is at a midpoint in the circle's arc length. Now here's another thing. Arc length can be given as displacement equals theta times r, and r being the radius. Theta is the angle subtended by the line in comparison to the x-plane or the y-plane. Now, here's the thing. In this point, we can see that sine 45 and cos 45 have the same values. That is 1 by root 2 or 2 by root 2, or sorry, root 2 by 2, whichever one you're more comfortable with. And you can see now why sine at 90 degrees gains a maximum value of 1, because the y value when the angle is at 90 will always be equal to the radius, which is 1. And you can see the same for sine of 0 or cos of 0 being 0 and 1 respectively, right? I think it makes more sense now if you are to compare values or you have, for example, a wave function. Now, if you are not a physics major, or if you have never ever heard of anything called amplitudes and wave motion, then this is not for you. But if you're curious, then I urge you that you follow along. So, you know, for a wave, it is given that the position of the wave, x, equals a times cos of omega t plus phi, where phi is the angle subtended with respect to the positive x-axis. Now it makes way more sense now how we get the position, as the amplitude is simply a scalar quantity that amplifies the actual position inside of a unit circle. Now at every point x, it is on the unit circle when you take it in terms of cos omega t plus 5, and the amplitude simply increases the magnitude of the displacement or position in this way. Hence you can see that it's more convenient to find the position of a harmonic motion or the position of a undamped harmonic motion. My apologies. You can find that the undamped harmonic motion is always easier to find using a times cos omega t plus phi. This is because this gives us the position of the spring-loaded mass at any point in time t for any omega that is equal to root of k by m, where k is the spring constant and m is the inertia of the overall body. Anyways, I would like to thank you for joining me today, and I hope that I was able to clearly make you understand what I am trying to propose here. I know there are no flashy drawings or editing or even a whiteboard, but I think if there is something to be taught theoretically, then using a whiteboard or using something to represent can help. But if at the core someone does not understand what the concept is, then even a whiteboard cannot help. And that is why I break down the most simple of concepts that does not even require a whiteboard. The only thing you need is your imagination. Thank you.